Okay, so I just wanted to provide some clarity and advice on our discussion this morning in class. First of all, I love arguing calculus with all of you, so that was fun. And second of all, I just wanted to hope that these drawings, I think, will provide some more clarity on what's going on, especially in letters C and D. So real quick, this is letter B. I actually did the integrating over the x-axis first. Or the rotating rather. So the purple here is the region that we were given, bounded by 2x squared, y equals 0, and x equals 2. That's the purple part here. And then rotating it this way about the x-axis produces this green part here. And again, this is two-dimensional, but you can kind of imagine you're going to have this thing, I don't know, some of you have been calling it like a tent, but it's filled in, or like an upside down cone looking thing. But remember, the point here is that we want to think about cutting this into little slices, right? Round slices, and these will not have any holes in the middle, and so we're going to actually use the disk method for this. And the disk method would give us a radius here, so from the center to the top is just given by the function y equals 2x squared. And we're integrating, since it's respect to x, from 0 to 2. Those are just the bounds of that region with respect to x. And then we'll get something like that there. You want to integrate this in order to find the volume of this 3D figure, okay? And then this is letter A, so this is about the y-axis, same exact region here in purple. This time we're spinning it this way. And so again, this is two-dimensional, but you can imagine what this would look like, kind of, you know, the inside of it is a bowl, but that, remember, is like a big hole. And then this is, you know, thick on the top, if you can imagine, but it's round. It's a little bit hard to picture. But what I like to do when I'm doing with respect to the y-axis, it kind of helps me to think about it. If I turn the paper like this, helps me to picture what's going on. So if I slice this thing like this, right, again, I'm making those slices in order to think about adding up a bunch of different volumes of very small width, you know, our dy in a sense. And so if I slice those, they are going to have holes in the middle. If you imagine that, you've got a circular region here, and then in the center you have a circle. So this is actually washer method, okay? So remember, with washer method, you have to figure out what's my outside radius, okay? What's this distance here, the outer radius of that thing that I made with the rotation, and then I have to subtract that hole. So subtract this right here, this inner radius. Well, first of all, I'm sure you solved to see that if I solve this for x, I would have gotten x equals, let's see, I would have had to divide y by 2 and then take the square root. So x equals square root of y over 2. And so if I think about that outer radius, so that's from here to the top of this thing here, that's constant, right? That outer radius is just 2, right? Anywhere that I pick, that outer radius is 2 because it's given by x equals 2, that bound right there, okay? So when I'm integrating, I've got 2 for that outer function, if you will, and then the inner one, the one that I'm subtracting, is actually given by the function, which in terms of y is this right here. So when you go to integrate, again, I'm writing sideways, but I think it makes more sense. You're going to integrate, again, you've got the pi. Remember, we have y this time, so we're going, the y limits are 0 to 8 of that little figure there. So 0 to 8, and then again, my outside created by this part here, this radius is 2, so it'd be 2 squared, okay? And then subtract that inside circle, which is given by square root of y over 2 squared. And then again, dy for all the little widths of all those washers, okay? So that's the front two. I think you got those right, but just so you know how those are set up. Moving on to the back, some great discussion today, but I just want to show you actually what's working here. We discussed today, you know, should this be the same? Should C be the same as if we were to reflect it this way across the y-axis? And in fact, it's not. And here's why. So I have, again, this purple region is the original, and then I'm going to rotate it around this time, this line right here, y equals 8. And so it's going to make the reflected part up here, which is the green. And again, imagine that that's three-dimensional. I'm kind of just showing you the side of it. But then if I imagine here, cutting these, making little slices, remember the idea is to think about how we could find the volume by adding up the volumes of all those little slices, okay? If you imagine slicing through this thing, your slices are gonna have, there it is, a hole, right? There's a hole in them, they're washers, okay? So we need the washer method, and again, we need to ask ourselves with the washer method, have to take that outside radius, which will be given, this is the outside circle, right? So that radius will be given by the distance from here to here, this distance. Well, how far is that? Well, let's think about it. How far is that? If I go from 0, right, up to here, this right here, that's constant, right? This is just a rectangle, so the distance from here to here is always going to be 8. And that outside radius then is 8. And then the inside one, so that's the distance from the center here to here, right? That is given by what? Well, think about it. This distance from here to here, it has something to do with 2x squared, except for it's not 2x squared. That'd be from here to here, right? It's the difference from 8 and 2x squared. It's this, okay? So that's given by, what is that given by? 8 minus 2x squared, okay? So when you set up that integral then, for this one, it is indeed a washer. Still have pi on the side. You're still integrating from 0 to 2, but your two functions this time are 8 squared, again, from that outside radius. The radius from the center to the outside is just given by 8. And then subtract that middle part, which is given by the function, but not just this distance here. It's actually this distance here of all those little radiuses. So that's going to be given by 8 minus 2x squared squared. Okay? And then again, dx represents all the little widths of each one of those little washers. Okay, so integrating that should give you the answer to letter C. Okay, which you will find is different than letter B. All right, moving on, lastly, letter D. Again, we have the same region. And by the way, we had some discussion about this morning, but this is the region that they gave us in the original problem. Okay, that was the beginning, that's the region, so we're not gonna change it based on what we're doing because this is the thing that we're supposed to do A, B, C, and D to, okay? So it's always gonna be that same purple thing. So that purple region, again, is from y equals x squared, and then x equals 2, and y equals 0. That's how we got that. Okay, again, we're going vertically again, okay? So if we're going vertically, we're gonna think again about kind of turning this on its side, and so then we're not using y equals 2x, but we're using our equation solve for x. X equals the square root of y over 2. And then we need to think again about doing this, right? We're rotating that. We end up with this thing that, of course, is circular on the outside, if you can imagine. If I imagine slicing it to figure out what those cross sections look like, or the little round circular things, they will not have a hole, and therefore they are discs. So in the disc method, we just need to figure out what is the radius. Well, let's think about it. So the radius, again, is from the center to the outside, okay? So it is from whatever this thing is here to the function that I have, okay? Well, what is that? That's just given by 2, right? 2 minus the function here, okay? Don't confuse that again like the one we just did. If I was just talking about the function, that would be the distance from here to here. But I want this distance, so that's the difference of 2 and the function, okay? So when you go to set your integral up for that one, you're still integrating from 0 to 8 with respect to y. You have your pi out front, but this time your r, capital R, is 2 minus this right here that we found before. So square root of y squared, and then again all squared because this has to do with the radius of those little discs, and then dy are our widths of each of those discs. So hopefully that provides some clarity, and I think the key is to make those pictures and see what the radiuses are, and that's really hard to do if you don't actually draw them and use your pencil and use your brain to think about what in the world is the radius of that if I were to slice it up. I hope that helps. Feel free to comment and ask more questions, but that's how you do that, and that should help you too with some of those questions on your worksheet, as well as when you are finding the volumes of your own objects. All right, sounds good, guys.